Hi guys, this will be a short video on physics chapter 1, and we'll be going over chapter 1.1, the subset of chapter 1, and we'll be covering this whole topic from points 1 to 8. And I have the syllabus open here. We'll be going point 1, point 2, point 3, so point by point. And I'll be using a third-party notes website called znotes.org. You can search it up. And this is IGCSE notes, but it works for O level and IGCSE both. The topics are exactly the same. So let's begin. Now, point 1 says describe how to measure a variety of lengths with appropriate precision using tapes, rulers, and micrometers, including the reading scale on an analog micrometer. So, important point here, you have to know how to read an analog micrometer. We will actually get back into that much later after we cover everything else, because this one requires a bit of visual demonstration and will require the help of YouTube on this one. Okay, so first of all, how to measure a variety of lengths. So they have already said what you will be using. You'll be using tapes, rulers, and micrometers. So let's get into the notes. And in the notes, three basic quantities: length, mass, and time. So first we'll be covering length. And here, though it is not mentioned in the syllabus, you need to know these things. So we'll be going over this first. Unit of length, meters. So you might normally know how to measure lengths by using units, and the units go like this: kilometer, hectometer, decameter, meter. So here, uh, kilo, hecto, deca, decimeter, kilometer, hectometer, decameter, then meter, then decimeter, centimeter, and millimeter. These will be taught to you from, I don't know, grade 5, 4. So you'll probably already know this, but you need to know much more than this now. After meter, so after meter, if you divide it by 1000, there will be, something, 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 let's just say, and then there will come millimeter. So m, let's just say millimeter. Then there comes, again divided by 1000. So when you move from this side to this side, it will be divided by 1000. So let's just say, division sign and then divided by 1000. Millimeter. Then there comes micrometer. So MICRO. Let's just write micro, and you can write meter, micrometer. Then dot dot dot. Then there comes nanometer. So NaNO. So yeah, micrometer, nanometer, and every time it's divided by 1000. So again divided by 1000. Again divided by 1000. So if you take 1 millimeter, right, 1 millimeter here, and slice it up 1000 times, one slice will be 1 micrometer, and nanometer going the same, like 1 micrometer. To slice it up 1000 times, take one slice, it becomes nanometer. And if you want to write nanometer in standard form, you can easily write it like this: 1 by 1 million. So a nanometer is 1 millionth of 1 millimeter. So because divided by 1000, again divided by 1000, and it will be multiplied. Though this seems a bit weird, or this seems a bit abrupt, but it's not that complicated. So here they have written it in standard form, and you can see. So decameter is not that important. Centimeter you already know. So it's 10 to the power minus 2 meters, and millimeter is also here, 10 to the power minus 3 meters. And then there is micrometer. Micrometer is written using this reverse U symbol, I guess, and 10 to the power minus 6 meters. M represents meters here, and nanometer is 10 to the power minus 9. So minus 6, and this becomes minus 9. So divided by 10, and so 3 more zeros get added to the power. If you are doing add maths, this will seem intuitive to you. O level or IGCSE add maths. This is called, I guess, SARDS. Yeah, SARDS and indices chapters. So this falls under that chapter, and you can manipulate powers and whatnot. they teach you that. Moving on, uh, there are more higher power. So this will these things over here, you can call them like low power measuring units, right? So because millimeter is very low, the distance, I mean, the actual physical distance is very small. Micrometer is even smaller. And if you go over here, there you can measure even bigger and bigger distances. It's kilometers, so 1000 meters, you already know that, kilometer. And in the notes here, you need to know one more thing, which is gigameters, I guess. So they're instantly going to gigameters, and you can learn something, one more extra thing here, which is, I don't know, 1 million meters. So kilo is 1,000, and then if you go in this direction, right, so it will be multiplied by 1,000, because if you are going to the right, it was getting divided by 1,000, and if you're going to the left, it will get getting multiplied by 1,000, because the units are getting bigger and bigger, and you can measure bigger distances. So you multiply 1,000 by 1,000, becomes 1 million, right? So yeah, 1 million meters, I guess. So let's just say AMK, right? Million kilometers, and then GK, billion kilometers. It's a bit crowded here, but let's just say dot dot dot. So if you multiply by 1,000 once more, it becomes 1 billion kilometers. Yeah, that's more or less it. So 10 to the power 9. And yeah, if you multiply it by 1,000, right? It was a million before, because 1,000 into 1,000, right? It becomes 1 million. And you multiply by 1,000 again, so 10 to the power 9. So there is 9 zeros here. That's why 10 to the power 9. Now, I hope it makes sense. And these are the units of length. And this gigameter thing will not come up that much, but the millimeter thing and micrometer thing might come up a lot. So you do need to understand how this works. Simply put it, recap. Millimeter, take this, divided by 1,000, micrometer. Micrometer, take this, divided by 1,000, becomes nanometer. Divided by 1,000 or multiplied by 1,000. Simply put it that way. You have to divide or multiply. If you want to go up the chain, meaning more powerful units, multiply. If you want to go down the chain, less powerful units, divided by 1,000. Okay, let's go to syllabus again. Now we can actually see what this tells us and what we need to know. So describe how to measure a variety of lengths. So what do they mean by this? I don't know. It could be variety of lengths, could be like a football field long, or I don't know, your table, the table you have in your home. How long is that? It's not a football field long. So how do you measure a football field? How do you measure the length of a table? What things do you use? What tools do you use? And you have three options here. You do not have anything more than these three options, like tapes, rulers, and micrometers. These are about it. Like the ruler here, sometimes people mention meter rule. Rulers, what rulers are, the 30 centimeter longer rulers or the short 15 centimeter ones. So you have that in your home, you probably use it in maths, but there's something called a meter rule, and there is just ruler but longer, ruler but 1 meter long, so 100 centimeter long. In your home you have 30 centimeter long, right? Take that, triple it and a bit more, so 100 centimeters, right? That's just a more longer ruler. Yeah, that's about it. And tape measure is basically a piece of tape. Yep, I know, very groundbreaking information. So a piece of tape, but there is centimeter markings and inch markings and whatnot written in the tape. So let's just say you have a you know big disc of tape and hole in the middle for spinning, and the tape just comes out this one end, and there is marking 1 centimeter, 2 centimeter, 3 centimeter. So if you want to measure something, just bring out the tape. Let's just say you want to measure this wooden block. Just bring out the tape and put the tape here in one end, and put the other end of the tape here, right? So the tape measure could be here and some of the tape could be here. So you just take measurement here, and see how much long this thing is. So this is a tape measure. If you want to see one, just search up tape measure on YouTube or on Google, and yeah, you can see one. So now that we have explained what a tape measure is, the last point would be, where do you use a tape measure? Where do you use a ruler? Simply put it, questions will come like this. A student is trying to measure a football field, and what kind of tools do they use? So they want to measure the length of a football field. Would you be willing to use rulers, right? Is a good question. And the answer will no. Like, a field is like very long. If you imagine a football field, and if you imagine trying to measure that with a ruler, you will need, like, I don't know, 100 rulers. Like, it will be very tiresome, very costly. Like, there is no need to do that. You can just use a tape measure. Tape measures are usually very, very long, like 1,000 meters. So easily you can measure a kilometer with that, because a tape measure can be rolled up, right? It can be rolled up and coiled up. It will take not much space, and it is like flexible, because this thing, right, this tape, it can be bend. It can, bend. So keeping it in this rolled up form saves a lot of space, and very convenient too, as if you need like 10 centimeters of this tape measure, the rest can be kept hidden inside and well protected, and it won't get affected by dirt or anything. So if you need 10 centimeters, just bring out 10 centimeter and use it, and just, I don't know, roll it back in. And if you need a kilometer, just take it out, use it, and roll it back in. So if you want to measure a football field, use this tape measure, the T so tape measure for football field. And generally, football field means a longer length. So if you want to measure anything longer than a meter, right, then you would be using your tape measure. Common sense. And anything shorter than a meter, you'd be using a meter rule. Why? Because you can use the tape measure 100%, but the tape itself is heavy. This thing, it requires you to, carry it around, and I don't know, keep it safe and whatnot. Because if someone trips in this tape, right, they will get tripped in the tape, I guess. So the tape will pull on itself and get tangled up there. So tape measure cannot, not that convenient. If you use a meter rule, so a very big ruler, and if you want to measure a table, it's very easy to measure, as the extra part of the ruler will be just hanging around in the side. It will not be that problematic. But if you get down to the details, tape measure and meter rule, not that different in terms of convenient. So yeah, in the real world, no one cares. But when the question asks you, if if you see the length is less than or equal to a meter, just say meter rule. No need to write tape measure. Tape measure is for longer length. So meter rule is for anything less than 1 meters. So let's just say, what is 1 meter? I don't know, like 75% of your body. Yeah, that could be 1 meter. Moving on, micrometers. Micrometer is a very weird thing. Probably no one has, none of you have seen this before. It is a very new instrument that is added to your syllabus this time. So on micrometers, I will come back, but generally micrometer is actually known as a micrometer screw gauge. So the whole name is a micrometer screw gauge, right? In short, they're calling it a micrometer here. So yeah, we'll get back to it. Now, point two. And also, yeah, if you want to write it down, right, where a tape measure should be used, where ruler should be used, you can write it down, obviously, but it's common sense. So no need to write it down if you don't want to. Describe how to use a measuring cylinder to measure the volume of a liquid and determine the volume of a solid by displacement. Okay, describe how to use a measuring cylinder. So first they're asking you to know how to use this thing, a measuring cylinder, and to measure the volume of a liquid. and to determine the volume of a solid by displacement. Okay, very interesting. So, what is a measuring cylinder? We can actually ask Google right now. MEA measuring device. So, put it simply, yeah, this is a measuring cylinder, and it's basically a flask or a beaker, whatever chemistry people can call it. You Let's just say you have a bottle of water. There is no marking on the bottle, and you drank out of the bottle, so it's half empty. You want to know how much water is left in the bottle. Well, easy way to know is just pour it into this cylinder. And this cylinder has also markings like a ruler. And the markings here go like 100 millimeter, 200 millimeter, and whatnot. So the spec on the whole beaker is basically whole measuring cylinder is 1000 millimeter. So that would be 1 liter, right? If you divide that by 1000, it becomes 1 liter. So if you fill it up to here, exact this line, it will be 1 liter or very close to 1 liter. So let's just say if I have the half empty bottle or half full bottle, yeah, you pour the water in and it comes up to like 400. So that means the half filled up bottle now has 400 millimeter of water. Sorry, milliliter of water. So how do you find out the volume, right? So you just find out the weight first. So this will be the amount of mass you have or amount of water you have in weight. So milliliters, let's just say 400 milliliters, and told they told in the syllabus to find out the volume. So how do you find it out? Use the formula. So go into the notes. Volume equal V equals pi r square h. So you need to know this formula, and you might be wondering how do you use this. So if you come to the measuring cylinder and the water is up to 400 mark, right? You take a ruler, then measure the length of this cylinder, or measure the length up to the 400-meter mark. So up to the 400-meter mark, let's just say you get 4 centimeters. So now you can use the formula V equals pi r square h. So you only need to find out the h, and h is you find out already using a ruler, 4 centimeter. Plug that into the formula and you get the V. Nice, you found out the V. And here is also a measuring cylinder. And as you can see, they have poured a liquid here. Now, the next part says determine um, determine the volume of solid by displacement. Okay, this one. So here there is water, and you have found out the volume, right? Using height. Nice. So let's just say you have an object. What object? So some kind of a rock, an oval rock like this. And you need to know how much volume this rock has. So what do? You take the measuring cylinder. You just drop the rock inside, right? With water. There should be a bit of water. So when the rock enters the water, it will sink to the bottom. And when it sinks to the bottom, the water level will rise up as you have added a bit of rock to it. So you just record the before level and the after level of the water, and you just subtract the difference, and this will be your volume of the rock, right? This will be the V of rock. Very easy. You just use the formula, take the h. So you measure the h using your eyes and a ruler, and then yeah, calculate the volume before and volume after, subtract it. Again, you can write it down, but this one also not that hard to remember with common sense. And next one, part 3 or point 3, describe how to measure a variety of time intervals using clocks and digital timers. Clocks and digital timers, and this one doesn't have much to it. Like even in the notes, Yeah, there is only this much on it, and it's still pretty easy. How to use clocks and digital timers. So clocks, no one uses clocks, I guess, in physics. Like syllabus mentioned here once, and probably will mention it never again. Digital timers, sure, but people mostly call it stopwatch. You know, yeah, we only use stopwatch here, nothing more, nothing less. And what is a stopwatch? You've probably seen it when, people use it in a race, some kind of a marathon or a horse race or a human race, any kind of event where time keeping is required and the accuracy is also required. What do you mean by that? So if you use a stopwatch, it will be a round thing and there will be a display in the middle. So display in the middle will show, the minute mark. So let's just say 1 minute and then 30 seconds and then it will show a bit more. So it might be able to show up to, I don't know, 1000 milliseconds. So let's just say here, yeah, 1000. So it is actually, you have to write only 100. So it can technically show up to, 000 is a thing, and then 999, right? So it can show up to 1000 milliseconds. So this is a very high level of accuracy as you can go down to the, I don't know, 1000 millisecond, right? So let's just say someone came in a race, right? Someone came in at, I don't know, 101 2 second, right? 101 2 milliseconds, and someone came in after, like, I don't know, 100, let's just say 19 milliseconds, right? 19. So if you did not have the last column, right? If you did not have this zero, then both will be 11 11 and they will be tied. But if you have extra column here with one more zero, so you can give like extra amount of precision to your timing. So now, as you can clearly see, there is a 2 and there is a 9. So this guy took much more milliseconds than the guy on the above. So this is why stopwatches are used. And stopwatches are basically used everywhere, variety of time intervals. So if you want to measure something like, you know, 10 hours, 20 hours or something, some kind of very long process, then you can use a clock. So I don't know, the analog clock in your house or the digital clock in your walls, stopwatches are not needed there. So after that, point number 4 is determine an average value for a small distance and for a short interval of time by measuring multiple such. So determine an average value for a small distance. So how do you take an average value? You just, you know, take a bunch of values. So let's just say you want to measure a table. So you have a table here. You want to measure, just take a ruler, measure, keep it on this part and this part. So take a measurement here, take a measurement here. So let's just say it comes up to 7. And let's just say you have to take a measurement again and the ruler is broken or crooked or a bit bent and the object is also a bit hard to measure. You can get 8 again, right? Because depending on where you stand, right? If you stand here and then measure, your eye will see, let's just say, this part, and if you look from directly above, your eye will see something else. So depending on that, you can get 7 8 7 something like that, 7.6, right? You take these things and, add it up. 8 plus 7.6 divided by 3. This is how you do an average. Take the things you have, add them up, and divided by the number of things you have. 1 2 3, this is the number of things I have. And let's just say I had 12, then here I could just add up the 12 and take an average, and then this 3 would become 4 because we have 4 things here, comma comma. Okay, so now we know how to do an average. So take a reading of the distance per short interval of time by using multiples. So this is what they mean by measuring multiples. So you measure something multiple times. And short time interval also same thing. There is a thing called a pendulum, right? There's a pin here and a string and a ball here. So it goes from here to here, here to here, here to here. And this thing is a bit fast, and it can help you keep a track of time, right? So you have to measure how much time it takes from the for the pendulum to go from here to here and then back, right? So go to this place and then come back to the original place again. And you have to press your stopwatch exactly when the pendulum reaches here, right? And this is a bit hard to do. It will come here, and then it will slow down, it will stop, and then it will go start going back again. And you have a very short window to actually press the stopwatch, and you might miss it, right? Sometimes you might press it a bit early, sometimes you might press it a bit longer, so you might get like, you know, point 0.8 seconds, right? 0.8 seconds, comma 0.9 seconds, comma 0.11 seconds, right? 1.1 seconds. So if you take all that up, add it up, right? Add it up and divide it by 3. You have now an average, and this is more accurate, right? Because you took a lot of readings. So the mistakes you are making, they will try to cancel each other out, because you have taken zero point 0.8 seconds here. It should be 1 second, right? But you got 0.8, so it's a bit less. And you got a bit less again, and you got a bit more than 1 second, right? They cancel each other out. Moving on. So yeah, this is what I mean by average value. Multiple measuring multiples, time and distance both. So next point is, understand that a scalar quantity has magnitude, size only, and a vector quantity has magnitude and direction. So scalar and vector, you might have read this before. So scalar and vectors are basically something called a physical quantity. What is a physical quantity? We'll get into that. So physical quantity is basically something that has a unit and can be measured, something like that. So let's just say weight, right? Weight can be measured in, I don't know, like, basically I'm saying weight can be measured here in kilograms, but basically this is mass. So let's just say mass can be measured in kilograms, and this is the unit kg, and mass can be 5. So it has a value, numeric value 5, and a unit kg. So this is a physical quantity. And physical quantities can be a force, so 5 newton. So this one is actually the weight, and this would be 50 newtons. Anyhow, so what is the difference between scalar and vector? It is already written here. Size only, and vector has a direction. Okay, there are more physical quantities, but let's just work with these two, kg and newtons. So kg is your mass, and your mass doesn't have any direction. What do I mean by that? So when you're standing on earth, right, and you're standing on earth, your mass is basically the particles inside. It does not have any direction. It just has, it just has the property of how many atoms or particles there are in your body. It just doesn't have any direction. You could be in space, you could be anywhere else, like, a direction is not involved here. But 50 newtons is a force, and force always has a direction. And I'm calling this a force. This is actually weight also. So 50 newtons. You take a ball, you push it to the right side. The act of pushing it requires a bit of energy, and this energy can be provided by a force. Let's just say 50 newtons here. And this 50 newtons is the amount of force you're providing. At 50, it's a number. So you could have 1 newton. It would be a bit less. So it has a numerical value, a number, and it has a direction. So rightwards. It could be left, it could be up, it could be this way, it could be that way. It could be any other way. Infinite number of ways. You could push it upwards, you could push it downwards. This is what they mean by direction. It actually has a direction you're pushing it into. So the direction actually matters. If you push it left, it goes left. If you push it right, it goes right. So this is the only difference. It has a size, it has a direction. So the notes are here. There is a bit of examples provided. So scalar quantities, distance, speed. You should actually write this down, right? The examples. And this one. Write this one down. Distance, speed, time, mass, and energy, temperature, pressure. And vector examples. So gravitational field strength. This one is not needed. So this is a bit too long, a bit too complicated. So throw these two out. And electric field strength. Just use force, then weight, velocity, acceleration, momentum, right? Include these ones. You just have to memorize them, right? You do not know what acceleration is, you might ask, and there is no need to know it right now. Momentum also, we'll get into that just a bit further in. It's in our syllabus, and a few classes down the line you will know what these two are and what velocity and what is weight and why it is different from mass. Moving on, know the following quantities are scalar. So yeah, they have already provided these things as an example. And the last point, determine by calculation or graphically the resultant of two vectors at right angles. Let's see this. So as I said before, a vector can be any of these ones: force and whatnot, and electricity and electric field, weight, velocity, acceleration, momentum. So for now we'll be only considering force. So what is a vector? Let's just say a force here going this direction, 5 newtons. This is a force, and this is a vector also, this is going to the rightward direction. And then imagine a ball. This ball is going this way with 5 newton force, and then you provide the ball with an upward force, a slight upward force of, let's just say, 2 newtons. So imagine this: a ball is rolling on flat ground, right? You kicked it, it's going straight to away from you, and somebody pushed it a bit to the left side of you, right? Pushed it a bit this way. The ball would do what? It would go forward, then when it gets pushed, it would start going this way. And this is the same concept here. The ball is going straight, it will start going straight, straight, straight until this force is applied. When this force is applied, the ball will start going this way, right? So basically, now you have to represent it in some way. And the syllabus says here, by calculation or graphically, the resultant of two vectors at right angles. So right angles mentioned, and you can do this anyway by calculation or graphically. By calculation, how do you do this? So let's just say they give you the question, and the question is like this: there are two vectors, one going this way, and then let's just say one going this. This is 2, this is 3, and they say find out the resulting vector. Simply put it, you can do this by what is called a triangle method. You connect this up, right angle, and this is the hypotenuse. You find this out by Pythagoras theorem. So a square plus b square equals c square. Easy enough. Now this line you drew, this is actually the resultant vector, right? So the ball was going this way, so the result in the actual vector, the resultant vector, after combining these two, the result would be this way, slightly upwards and to the right. So this direction, it matters. Exactly right, it was going exactly right before, and now it is going to the right but slightly upwards. As this is a vector, the direct he cares about the direction, so we have to mention j. This is going right and upwards, and you do this by using an arrow here, arrow and a line. So this line, right, I got this line. Where is the arrow gonna go? Over here or over here? How do you find that out? So basically you look at it, right? You look at it, And what do you see? Well, you have to observe where the original vectors were. One was going up, one was going to the right. So, and this will be the same thing, right? It will be going rightwards, so rightwards and slightly upwards. And okay, I made a mistake here. So the triangle method works like this, and this is called the head tail method. So you just have to draw it a bit differently, right? You have to draw it like this. Head tail method, what? How does that work? So you have to connect the head to the tail. So there is a head and this is a tail. So you can point this out, HE head. This one's the head and this one's the TAIL. This is the head and this is the tail. So you have to if there are two vectors, you have to connect the head of one vector to the tail of another vector. So you do this by simply take this as the base. Then as this is the head, you connect the tail of the other vector, this one's tail to this one's head, and it becomes like this. So now you draw the resultant vector, and it will be like this. It will be going to the upwards direction, right? So the resultant vector becomes this. And of course, if you use Pythagoras theorem, you can find out what the Newton value is. So let's just say Z, you know, I don't know, for there's a 3 newtons. It's again 3 newtons upwards and to the right. Simple-ish, I guess. And it works with most of the vectors and whatnot. And you don't even need to draw it like this. You just can see it and guess. But you can write down the method, right? It's called the head tail method. This is the head, this is the tail. You can draw it, right? Draw it in your own way, draw it nicely. I'm just doing it here to make everyone understand. So there is the graphical method they mentioned, but graphically it does not matter as they do not provide you a graph paper. You can try to do it without a graph paper. This is possible, but the calculation is much more easy because you just use Pythagoras theorem. It takes 20 seconds, and you can find out the direction also using the head tail method. So that actually covers the topics 1.1 includes. I know I said this is going to be a short video, but it took a bit longer than I thought.